Hey, it's Mrs. J. So I'm looking at series practice number 5, classwork assignment that we did on a series schematic. If you haven't done it, just a simple walkthrough to help you get started. So it says to try it on your own, work it out in your notebook, and upload your work when you're done. So we need to draw a schematic, and then we need to find the resistance, the current, the voltage across each of those little resistors, and then we can verify it when we're done using Kirchhoff's for series circuit. So you want to make sure you show your work using the units and proper engineering notation, and I'll guide you through that. Okay, so the problem says I want to put a string of battery operated lights on my Jeep for a holiday parade. I have a set of lights with 50-volt battery and 5 lights. Each of the LED or the light emitting diode lights has a resistor with these values: 5 ohms, 3 ohms, 4 ohms, 7 ohms, 6 ohms. So the first thing we want to do is draw a schematic. I can't really do it on my screen right there, so I'm going to do it by hand, and then I will show you the picture. I'm going to draw my power source, and I'm going to draw a simple rectangle with 5 resistors on it. 1, 2, 3, 4, 5. So this is how I start it. I know there's 5 because I'm looking at this right here, right? And then if you look at my screen down here, this is how I started it. So I've got my power source and 5 resistors, but it's not a schematic until I label it with notation. So 50 volts for the battery, 5 ohms, 3 ohms, 4 ohms, 7 ohms, 6 ohms. I didn't have them space them out evenly across that rectangle, but you figure they're on a string of lights, they have some space in between them. So I did, let me see if I got all that straight, 50 volts on that battery, and then the ohms for each of them. 5, 3, 4, 7, and 6. That is a series schematic for this string of lights. All you gotta do. So you're looking at the little screen down in the corner there. Okay, so the next thing says find the total resistance. So we have to remember the formula for finding the total resistance, and in a series circle it is total resistance, should be an upkeys. Total resistance is equal to each of the resistors added together. So there's 5 resistors up above there, R1, R2, R3, R4, R5. We need to write the formula, R1 plus R2 plus R3 plus R4 plus R5. I have 5 lights. 1, 2, 3, 4, 5. And then if you wanted to do the subscript, I just highlight and control comma on my keyboard. Control comma. And if you want to get out of it, you do control period. So it looks proper. And then you just need to, let's see, control period, so I can get back up, is equal to, I think I'm in the wrong thing. There we go. Okay. So it's going to be equal to 5 plus 3 plus 4 plus 7 plus 6. And your answer, add those together, and your answer is in ohms. So you just type ohms. Don't forget that. You can do the math on that. You can do it in your head. The next part says to find the total current. And I typed the word series so that you would remember to use the series formula. The regular formula is Ohm's law. V is equal to I times R. That's where you start. But it says find the current. So I want to switch it to I is equal to V divided by R. So you have to look at this and say, well, the I and the R are together, multiplication. I want to do the opposite, divide it and move it to the other side. So I is equal to V divided by R. And that is not enough. You'll need to, oops, give me that. Don't give me my arrow. There you go. You need to plug it in properly. So many people can get that far, which is great. Also have to enter it in. We had a 50-volt battery, and we should have gotten 10, 15, 25 in when we added the total resistance. So 25, and I think I have an ohms up here. I can copy ohms. It doesn't need to be volt. Okay, so 50 divided by 25 is 2. Your answer is in amps. Put in your number 2. And then you need to use that 2 to find the voltage across each component. So what we're talking about is on your schematic, you have 5 lights, and you know what their resistance is. They each have ohms, right? We need to take the current, which we just found in number 3 and 2, and get that in there. So let's use the right formula. What's the voltage? We know that V is equal to I times R. And we're going to use this formula for 5 times in a row. So we're going to overdo it each time. So I'm going to do it for the first resistor. And I'm going to do it again for the second resistor. You remember this part now, right? And I'm going to do it again for the third resistor. So get that in there. For each one of those, I'm going to say that the voltage is equal to 2 amps, because you got that answer in number 3. If you got something different in number 3, go back. In a series circuit, the current stays the same. So I'm going to use that number 2 for all 5 of these. So it's 2 amps times whatever that resistance was. And the first one was 5 ohms. So Control C. And remember, we're multiplying here. I'm going to use a star because the X gets a little messy. So 2 amps times 5 ohms gives you 10 volts. And then you just need to repeat this process for each of the resistors. You can actually just get in here, Control C, and then change this for each one. I mean, no need to like overdo it, right? I'm going to do that each time. I'm going to do it for number 3. You need to show your formulas to get credit. You can handwrite this. You should handwrite this. It helps you understand it better. That's what I did in college. Handwrite over and over. Repetition actually helps. I know people say it's busy work. When you're doing calculations, all of a sudden you do it forward and backwards and your brain's like, oh, I get it. And when you got it, that's when you can stop writing. I'm still writing and I've been doing this for years. So I'm going to take the resistor now for each one of those. So I got my current. I'm in a series circuit, so it's always going to be whatever I found in here, number 2. And I'm going to do each of these resistors. So 3, 4, 7, and 6. And I'm just going to steal them from up here. 3. And then the next one was, I think it was, oops, 4. See where I'm getting my numbers from? Up above there in the LED values right there. And I'm just using my formatting because I have it. 4, 7, and the last one was 6. So I can leave you to the rest here. 2 times 3 is 6 volts, and 2 times 4 is 8 volts. Get a little bit neater. So make sure you write your formulas, you enter the info. I know it's simple and you might feel like, why do I need to enter the info? It's to help your brain connect. So take a minute, you can do it. And then the last part says number 5. verify using Kirchhoff's law. Kirchhoff's law says in a series circuit, the total voltage is going to be equal to the sum. So you add them all together, and we have 5 of them, and they should equal what my battery was. And I actually did this in my Jeep. I had a 50-volt battery, which is a weird squarish thing. And I ran some lights across the top of my I have a big light bar, and I ran some colored lights on top of that. Just for fun. I mean, why not play with it? So V1 plus V2 plus V3 plus V4 plus V5 is going to be equal to hold on just a second. May as well do it in proper notation. It only takes a minute to make it correct. So now you're using your answers that you picked up in number 4, which would be 10 plus 6 plus 8 plus 14 plus 12. You should get 50 volts as your answer. As long as you're close, when you're doing this in real life and you take some measurements, as long as you're very close, you're good. Got a 50-volt battery, and that's what I'm trying to prove right here. So we already know what it is, but Kirchhoff's law helps us make sure that we've done it correctly. Thanks for watching. You should handwrite this in your notebook and turn it in. Make sure that you do your hand-drawn schematic. And I think there's some software out there that you can use. You might want to add the current to this. So I is equal to, we figured this out in number 3, 2 amps. And to add the current, you put that arrow right there. Oops, I can't do this backwards. The arrow plus current, 2 amps. And good to go. Thanks for watching.